Now I'm going to unlock your mind and make you learn programming. This is the channel Computer Science and Sports. So all the things that our five senses can capture are much more intelligible than those that we cannot capture with such senses. We know that chairs, beds, fridges and etc. exist because our sense of sight detects them. When we have to deal with programming, however, we must face a world in which things are not tangible. A world made of characters, strings, numbers, expressions, loops, and etc. A world where artifacts can be indiscriminately replicated and new concepts be in an even further layer of abstraction in this already abstract world. Another thing that impedes us from learning programming is the manner we tend to judge ourselves as knowing something or not. Why learning to program for some technology if after some time it will become obsolete? This, I believe, is a mental barrier that exists because we judge ourselves as being good or not in something based on what we mentally have memorized, not on what is our capacity to, in an adverse situation, with a given amount of tools like a notebook and the internet, overcome these adversities. Programming is difficult, and it remains being difficult no matter how experienced you are. The difference between good and not good programmers is only how much they practice and how open they are to the fact that, independent from how experienced they are, there will be many more things out there in programming that he will have to learn in some moment than things that he has already memorized. Perseverance is the key to programming and also to life. In this extremely initial lesson, I'll make an introduction to the most basic notions of algorithms and programming. I hope that it unlocks your mind such that one day you look to yourself and see that this lesson was worth it. So come with me and I will unlock your mind for programming. When you want to teach something to someone, you generally divide what you want to teach in tasks. Each task must be interpreted by the person to whom you want to teach. The same works for computers. Let's make an algorithm for making fried eggs. All the elements, objects that we need we will call inputs, and the end result we will call outputs. The inputs are an egg, a plate and a microwave, and the output is the plate with a fried egg. So the sequence of steps of the algorithm is as follows. Put the dish on the table, get the egg in the refrigerator, put the egg on the dish, break the egg, put the dish in the microwave, put the microwave to heat for 1.5 minutes, and take the dish out of the microwave and put it on the table. Very easy, isn't it? Nevertheless, try to imagine what would happen if you change the place of instructions 3 and 4. You would firstly break the egg and then put it on the dish. Can you see what's the problem here? So, you break the egg before you put the egg on the dish. If you break the egg before you put it on the dish, you won't be able to put the egg on the dish. Not only you won't have the fried egg, but also you have lost the egg and have to clean the unexpected dirt of your kitchen. Of course that the person that processes this algorithm won't be that stupid for not seeing this mistake. But, and it is very bad news for us, computers are extremely dumb. If we don't give them a precise sequence of instructions, dirts like this can occur in the virtual world of variables and functions, procedures, methods that compose programming. And it can be a nightmare to detect and correct them, sometimes even bigger than the creation of the algorithm itself. The advantage, however, is that we can debug the algorithm as many times as we need in order to see what's happening during the processing. You probably would not have this chance with a human processor, at least not without annoying it. So now let's go to the virtual world of programming. This world is formed by variables like those we study in mathematics, functions. Here they can be much more sophisticated than those that we see in maths, and so on. Instructions and steps of an algorithm program can be input instructions, internal instructions, and output instructions. The input instructions are intended to receive data, like values that will be used by variables, that the user inputs, and output instructions are those that the computer gives to us, the users. Internal instructions are those that are used on the processing of the logic of the algorithm, like assignments and etc. Let's make a simple program algorithm in a pseudocode for summing two integers. So this is an algorithm, and we see that instruction 1 declares variables x and y, that is, it says to the computer that the program will have two variables of type integer, and instruction 2 stops the execution of the program until the user, that is us, type with our keyboards two numbers that will be stored on variables x and y, respectively, and instruction 3 makes the computer show the result of the sum x plus y in our screen. like that on the MS-DOS command prompt or in the Ubuntu terminal. Depending on the programming language used to encode the algorithm, it can be written in different manners. For example, a program written in C for summing two integers would be this one. We would have to include the library and then declare a function main and the body that is equivalent to the pseudocode we saw. So for now, let's consider only the instructions that are corresponding to those at the previous pseudocode. So instruction xy integer is encoded in C as int xy. Instruction input xy is encoded as scanf dd ex ey, and instruction output x plus y is encoded as printf d x plus y. A more simple encoding can be made using Python, as we show as follows. Then we have an instruction ab that receives both variables receives input values that are converted to integer values, and then the computer prints the result of the sum. So the code intertwined with P1. Another thing is that instructions 1 and 2 from the pseudocode are intertwined with P1, in P1. This instruction says that variables A and B will be assigned with input values that will be cast to integers, and instruction print A plus B corresponds to output x plus y on the pseudocode. It is important to emphasize that the program algorithm does nothing until we order the computer to process it. For the Python program that we considered, a possible execution would be formed by this sequence of steps here. So the user opens a terminal or a command prompt and orders the computer to execute the program. The user types 2 and presses enter. The user types 3 and presses enter. The computer prints 5 and finishes the execution of the program. So steps B and C on the execution correspond to instruction P1, and step D corresponds to instruction 2 when executed, when the program is executed. And this is a possible execution of the program. We can type 2 and press enter, can type 3 and press enter, and then the computer prints 5, outputs 5, and finishes the execution of the program. So on this presentation we made a very introductive and motivating lesson about programming. I hope that this lesson has given you the key to open your mind and your interest for this very important activity in our modern world, that is programming. So unlock your mind and learn programming. Thank you very much. Subscribe to this channel, like this video, push the little bell such that you receive notifications for my new videos, and make questions and suggestions on the comments.